Good morning, good afternoon, or good evening, depending on where you're listening. Welcome back to AI and the Future of Work. This is your host, Dan Turchin, advisor at Insight Finder, the system of intelligence for IT operations, and CEO of PeopleRain, the AI platform for IT and HR employee service. Thanks again to all of you, our loyal listeners, for making this one of the most downloaded podcasts about the future of work. If you enjoy what we do, please like, comment, and share in your favorite podcast app, and we will keep sharing great conversations ad-free. Wrangling information from data is a problem we've been discussing recently with really good guests like Derek Steer, CEO of Mode, and of course, Charity Majors, the effervescent CTO of Honeycomb. Data used poorly or poor quality data used responsibly both can have catastrophic consequences. The role of the data scientist is really to understand the right questions to ask and then verify the integrity of the outputs from analyses, whether they're generated manually or via AI models. Today, we go to the top of the food chain for a discussion about high-stakes decisions using highly sensitive data. It took us, I think about 3 months to schedule today's episode, but I promise it'll be worth it. Scott Zoldi is the Chief Analytics Officer at FICO, where he served in various roles for about 19 years. Scott and his team are on the front lines of all of the themes that we discuss weekly: data, ethics, AI explainability, and certainly the future of work. Scott's teams are responsible for everything from detecting fraud to credit risk to money laundering. Scott has a PhD in theoretical and computational physics. He's also an adrenaline junkie who enjoys off-roading in his Bronco in his spare time. If you're not already, follow Scott. He's at Scott, Zoldi, Scott Zoldi on Twitter. Thank you to Benjamin Baer, a friend of the podcast, for the introduction to Scott. And without further ado, it really is my pleasure to welcome Scott to the program. Scott, why don't we get started? Maybe share a little bit about your background and how you got into the space.
Yeah, I'm happy to do so, and great to be part of the podcast here. I am a physicist, as you mentioned. So I got my PhD in physics, and during my PhD, I was focused on chaos theory, right? So understanding complexity in data and trying to make predictions when there is almost nothing to grab a hold of and make a prediction around. And I got really enthusiastic around understanding how to make predictions from complexity. So after the PhD, I went to Los Alamos National Lab. I continued a lot of that research, but it soon became very clear to me that some of the best problems to solve when it comes to complexity and prediction of behavior is actually in consumer data. And so I became very interested in getting into that space and getting at some of those data assets to continue my thinking around how to understand what is normal or abnormal associated with customer behavior, how to make the proper and high value predictions from this data, and how not to get fooled by noise and things that are really spurious, let's say in a transaction history associated with a customer. And that's kept me at FICO for about 2 decades, right? In terms of working with this data, understanding what our kind of unique IP and machine learning that we can use to build different types of models to enable business decisions. But beyond that, also focused on really driving kind of what is required out of AI and machine learning to the standards that we have today.
We're all familiar with FICO and the brand from our consumer credit scores, but I know that FICO goes way beyond that. Maybe talk about what's the core business of FICO.
Yeah, so FICO as a company is an analytics company or machine learning company. We are experts in leveraging data to make decisions, or whether it be the credit risk decision that you mentioned, but also things like fraud detection or money laundering detection, or even marketing recommendations. And so we focus our time and energy around how to build responsible AI models. And what I mean by that are models that are robustly developed around a very well-defined, documented sort of process that we use across all of our scientists, ensuring that those models are explainable or interpretable, right? So that we know exactly what drives those decisions. Doing the necessary work around stability and ethics testing to ensure that they're ethical, right? And then finally, putting all that around like an audit chain so we can make sure that when they're used to make decisions about people's lives, that we can point back to exactly why the machine did what it did and made the recommendation, so that we can explain that and enhance those decisions. So that's what FICO is about, is enabling those decisions through analytic models and machine learning models that based on the data that's available today in this digital world, and doing that responsibly and carefully and at high value for those customers that leverage these models for decisioning.
So take maybe one of those use cases, monitoring for credit fraud, or maybe determining credit risk. How would you explain how your team uses data, the data sources, how the models work, just kind of to a 10-year-old? Like what's the most simple way to understand the work that your team does?
Yeah, so in the fraud space, right, the way I'd explain it would be, think about all the credit card transactions that someone has done with a credit card, right? And so you can that's understandable, right? We know where we use our card. We know what are the favorite locations that we shop. We know when do we tend to use this card. What do we use the card for? How much do we generally spend, and how often do we spend with that card, right? And in what geographic locations do we use the card? So if we think about our spending behavior, there's all these pieces of information that allow us to understand a lot about the person. So when we build these fraud models, what we're doing is we're building essentially a transaction profile that summarizes all that event information, right, in terms of past behavior, and into a set of variables that make a set of predictions whether or not it's likely or not you'd shop at this store at this time for this amount. Have you done it in the past? How often have you done it in the past? How recent was it? And what our models do then is to take that summary of all that historical data and the current transaction, and generate about hundreds to thousands of signals indicating whether or not it is likely or unlikely based on all that past transaction information. And then a technology like a neural network takes all those signals, and instead of having thousands of them, it boils it down to a single score. And that score is a probability of fraud. And that's where, based on the score being high, which is high risk for fraud, a credit card company can make a decision to block that transaction because it's very unlike you, right? And it might be very highly likely fraud. But that's essentially what we do, is we leverage that transaction data. We come up with what is typical or atypical, and we come up with lots of opinions based on the data and the analytics to inform a neural network to make that decision.
I've heard you talk about the importance of AI ethics and explainability and kind of practicing responsible AI. And when you describe some of these kind of high impact automated decisions, I immediately think about what in the data science world we'd refer to as the cost of both a false positive or, of course, a false negative. So miss, someone who is a threat, or label someone as a threat who actually isn't. Talk us through, maybe just for starters, you're thinking about the role of ethical deployment of these algorithms when important decisions are being made based on them.
Yeah, no, it's a really important topic, Dan, and it's one that's kind of new, right? I mean, 20 years ago, it was all about the performance of a model, right? But now when we look at ethics, what we're looking at from an AI ethics perspective is a demonstration that the people that are building this model and those that will be using this model to make decisions deeply understand what are the nonlinearities or features that this model has learned that is influencing the way it makes the decision. So number one is understanding what drives that model, right? So we understand what data elements are sensitive to that decision. We can make sure that relationship is reasonable, right, from a stability perspective. If a client has a problem with the data source, right, they can go back and remediate that data so that they're not unfairly treated based on bad data versus what the model makes prediction around. But further to that, right, we have to make sure that these models are not biased towards different groups of people, right? And so we have to understand, by looking at each of these learned relationships, do they have a bias towards one group of people versus another group of people? And if it does, that's a problem, because that means that the model is going to, create more false positives or more for certain types of people than other types of people, and we have to remove that bias from the model. So AI ethics is then looking at how it performs in these subclasses. The last one I'll leave you with is AI ethics is also knowing when to step away from the model. When we produce a score of the model, very often it doesn't come with a certainty measure, like, I'm very certain about this score, I'm very uncertain about this score. The reality is, though, is that, I like to say with depending on the data, models can be more or less wrong. And so understanding where the model had plenty of coverage, meaning lots of examples on which to train, and would have a tremendous amount of confidence, then we have confidence using that score and making decision. Where a model may not have seen many people like Dan and Scott and is trying to make a decision that will impact our lives, right? Same model, an ethical use of that model would say, hey, the model needs to tell you that it's not so certain about Dan and Scott, so you don't take that score any more seriously than you have to. And these are concepts around safety and concepts like humble AI, which is a great term, right? It basically says, we can't trust the model as being all-knowing. We need to use it as the tool that it is. But all those things encompass ethical AI, and a proper use of these AI models in decisioning to allow people to reflect on that and to ensure that they have that as part of the decision-making process.
I'd argue public trust in AI-driven decision-making is perhaps at an all-time low. We're recording this in October of 2021, and the Facebook manipulation of the news feed and Instagram, there's a lot going on that are making people question the veracity of these models and data and who owns the data. There's another high profile example, this goes back a ways, but Amazon's facial recognition algorithm misidentifying like half of Congress people. And to your point, kind of this, I love that term, by the way, humble AI. One of the issues was that the models hadn't been trained on a distribution, an equal distribution of racial, of colored faces. So it underperformed when the faces were colored. How do you think we as a data community can restore the public faith in the use of these models to make decisions?
Yeah, it's an incredible challenge in today's environment, right? And I like to look back at my career, and 20 years ago, people were very skeptical about models, and they asked a lot more questions than they do today. And over the last 5 to 10 years, people just assume that they're always correct. And now people are reflecting, right, and understanding that there's many high profile cases of models that are not behaving well. One of the things that I encourage all data scientists to do and businesses to do is to change their mentality, right? It can't be about profit first, and it can't be about prediction first. And so what I like to tell people is, explainability first or interpretability first, and then prediction second. Okay, what is the priority? Is the priority to ensure that we understand the model and we're not mistreating people with this model, or is it the prediction, right? If you look at a machine learning model and the way it's built today, most algorithms just say, I'm going to minimize the error that I make in terms of prediction. Very few, the algorithms we use at FICO put explainability and constraints in there to emphasize explainability or interpretability as one of the number one desired traits of our models. We need to change it, right? And I think we're seeing more and more guidance in the industry around the same concept, right? Like, it's okay to have a less performant model that is ethical and that is fair. And so, one is we as a data science community have to put that front of mind, right? We can't be rewarded for a little bit extra performance and a huge amount of risk to doing harm to individuals. The other major aspect of this is that we need to, in making that real, right, explainability or interpretability first and prediction second, we may have to choose technologies that we can stand behind and we can demonstrate that we understand exactly how they work. We can demonstrate that at the time we built the models that none of those features or learned features in the model training process are biased towards protected groups, right? And then we put that on an audit trail, essentially, what we call auditable AI, which would also enable us to monitor it moving forward, right? So, one of the great things that I like about ethical AI is, you're not ethical with your AI when you build the model. You're only ethical when you start to make decisions. And so it doesn't really matter what you do in the lab, right? What matters is that you are monitoring in production that it's ethical. We did a survey of like 100 CAOs and CDOs and chief AI officers. Only about 20% even monitored their models, right? And they weren't monitoring for things like bias drift. So I think the public has to hear this. They have to understand this, and they'll end up demanding it, right? If their lives are being impacted by these models. So I see a shift. I think we are at an all-time low, as you say, Dan. But I think we are now in a position where so many researchers are waking up to the fact that this has to be solved. And I think responsible and ethical businesses are also understanding that it's not about the almighty buck. It's about meeting their business objectives while also ensuring that they're doing that ethically and safely.
It's a great way of phrasing it, that you only really demonstrate the ethics of AI in production. Because at training time and at design time, the algorithm is not inherently biased. And certainly at design time, you never design a system intending to introduce bias, but it's when it starts making decisions that you need, to your point, and also a great term, auditable AI as a practice.
Absolutely.
So now famously, Facebook trained a conversational AI model, and it was able to get two bots to invent a language that no humans could understand. And so here we are, you speak very eloquently about, what explainability is and how you instrument into your systems. And yet, in some cases, you mentioned, using neural nets, they're deep, there's so many layers. Is it reasonable to think that AI will be fully explainable when we use these deep neural nets to make decisions that are really technically very hard to unpack?
Yeah. So the way I'd answer it is this, right? I think it has to be an objective that will be achieved, right? And what I mean by that is, and we do this today at FICO, right? There's certain algorithms that I don't allow to be used, right? Because they are not explainable, or they're very difficult to explain, or they don't meet the rigor of explainability, right? As an example, we have an entire set of work that we call interpretable machine learning, right? So these are actually still neural networks, but they're very specialized neural networks. They're very sparse, and each latent feature only has two connections, right? So the relationships are very easy to understand and deconvolve, and we constrain it to a point where ourselves and our business owners and even regulators that would look at a model like this could explain what those relationships are. So I think, we can get to a point where we can explain these models, right? There are classes of machine learning models called interpretable machine learning models. But it means that we might have to give up the big, deep, neural networks, right? Even though they're cool and even though they're vogue, right? Maybe we leave them in image recognition and not in credit risk, right? Which have a tremendous impact on everyone's life, right? More importantly than, maybe an image recognition that will get a decision wrong. And it goes back to your earlier point you made, right? When we look at explainability or interpretability, and I'd rather use the term interpretability because it's much more concrete, right? We need to understand that the cost of making a wrong decision, right? And that's why, like in the EU, they have EU regulation that talks about high risk decisions, right? And they have facial recognition and use of AI in policing as high risk. They also have credit risk, right? Where, the loan decision that gets made is very, very impactful for somebody, right? And in those environments, what I would advocate for is where explainability or reasons for why the decision got made really matter. Choose a technology that is interpretable, not just explainable, where we would take a explainable AI algorithm, put it on top of a model we can't explain and get some sort of, plausible reasons, right? We may have to go down to a whole different level of explanation to a customer. And in fact, in places like Europe, right, you need to give them succinct and real answers in terms of what caused the score to go a particular way, so they can act on that and they can improve that outcome if they need to or wanted to. And that's a whole nother level of explainability than using SHAP methods or LIME or some other technique, which is, just talking more or less about importance of features, not around what were the three things that really impacted you, Dan, and not getting the loan that you wanted, let's say.
That takes a lot of integrity to be able to look at an algorithm that might perform very well and reject it because it's not interpretable. Talk us through their meetings that you actually have with your team where someone needs to make a call on, potentially rejecting a better performing algorithm. Like, any examples of where you've had to, stick to your principles because you were concerned about the algorithm not being interpretable?
Yeah, no, there's a number. I mean, so in the kind in different flavors. Sometimes we get data from our clients, and sometimes the data is dirty and has to be triaged. Sometimes this data will have outcome data in it, and when we go and look at the outcome data, for example, we'll see instances where people will put fraud and risk data together, right? And say just build a model based on this, right? But what that means is that people that are, when you combine those two things, credit risk and fraud, into a single model, you might be building something that predicts the loss to the company, but you're going to treat the individual very differently if you get a lot of fraud behavior in there. You're going to treat every credit risk person as a criminal. There's nothing criminal about credit risk, right? This is something that we all grapple with in terms of our obligations to pay off our loans. And so that is an example where we'd say, no, we're not going to build a model that way, because we know that the model will start to infer certain types of behaviors or certain types of individuals, and maybe treat them more fraud-like, where it's actually credit risk behavior, right? They simply don't understand lending, or they're hit hard times, right? Like, we don't want them to be classed in such a way that they'd be interpreted as someone other than dealing with a credit risk issue. Another example of this is just the latent features. We will routinely remove these, in terms of building these interpretable neural networks, we'll extract the latent features that, say, what are the relationships that drive these outcomes. We'll look at it by hand, right? Or with others in the business that will look at it and make sure the relationship makes sense. But beyond that, we'll go test it. And if we see any level of difference in terms of performance across different classes of individuals, or oversensitivity to maybe changing times, where this might cause the model to become oversensitive and maybe misbalanced in terms of its ethical usage, we'll remove it also. All right. And generally, I don't see much pushback on that, because I think we all want to achieve models that are not not behaving in ways that are unstable, which would be unsafe, right? And particularly during the pandemic, we saw lots of models go unstable, right? Or models that have some of this bias very deeply baked into it, and so that's how those conversations go. The other trick of this, Dan, is sometimes we will deliver maybe a lower performing model, but in reality, when you look at it out of time, right? If you ran both models, right, the one that looks better in the lab actually degrades much more quickly in production. And it comes back to that monitoring comment, right? Which is sometimes, it takes some time to explain that to scientists, but, time and time again, you take those two models, one that appears a little bit better, and you put it in a production environment, and it actually is not as robust. It's more unstable. And ultimately, the customer would be better served with one that is built more robustly, more stable, and certainly ethical. It doesn't degrade as quickly. Customers aren't treated poorly, and the businesses that use these models to make decisions actually operate a lot more effectively in that environment, also because they're not changing their strategies to a model that degrades, right? And that in itself creates situations of bias or differential outcomes.
Let's engage in a thought experiment here. So, as increasingly automated machine learning platforms or AutoML platforms become prevalent, and they're doing everything from automated algorithm selection to hyperparameter tuning, feature selection, drift detection, like a lot of the core things that we think about as encompassing the role of today's data scientists. 10 years from now, what is your team of data scientists doing?
Yeah. Well, I generally believe they'll probably still be doing a lot of what they do today. I think AutoML and technology like this have a lot of advantages of being, really powerful tools at providing insight, maybe challenger models, right? But, if we're in an environment where we have to deeply understand and have a human engaged during the training process, and ensuring that these models are meeting the regulatory requirements and are not biased or unstable, I think we can't remove the human from the machine, right? We are the kind of oversight of ensuring that the models are built properly. I think AutoML and technologies will help us be faster, more nimble, quicker. But I don't think it'll be a situation where it replaces data science. It'll probably just enhance their ability to do that. With that said, though, Dan, if I'm wrong, right, and AutoML takes a much larger role, I think the sophistication has to, increase, in terms of these AutoML technologies around things like, we're only going to use an interpretable machine learning model, right? We're not going to go and build the very best model. We're going to build the models that meet the regulatory requirements. And then, what are the outputs of these AutoML algorithms that would now enable myself and my business leads to review the things that drive the models and the bias. So it could go that direction also. But I think right now, right, given where we are in the low point, as you mentioned, right, the role of the human overseer is probably going to be preferred to, AI that's building AI, basically, right? It's kind of compounds potentially a problem, particularly in this view of responsible AI and this sort of oversight into how those models get built.
Great explanation. I maintain that anything that can be predicted is better left to machines, but anything that requires judgment or rational thinking is better left to humans.
Agreed. Yeah.
Good. Well, Scott, it feels like we're just getting started, but I got to get you off the hot seat, but not without one last question. So polish the crystal ball. Tell me about one technology that will be common in the workplace in, let's say we'll use the same time horizon, 10 years, that today just seems like science fiction.
Yeah, so I'd say this. I think AI augmentation will be one of those technologies. And I don't mean like we're going to all have chips implanted in our head. I certainly don't want one, right? But what I do mean is that I think that we will start to have these digital assistants that are enabling us to do our jobs better at work, right? And that might mean that, it's analyzing, what we're doing from, let's say I'm a case analyst and I'm working cases. They might understand how I'm working cases, which ones am I making mistakes on, where I might have, my own personal biases in terms of how I'm dealing with people or work. Inform me of that, right? And enable me to have additional insight on how I could become a better Scott Zoldi at doing this particular job. I think it also remove a lot of the tedium that we sometimes have to do in our jobs, right? To the point that you made around prediction versus judgment, right? I also like to think about creativity, right? And creativity is a very great human trait, right? But very often in many of our jobs, we don't have time to be creative, right? We actually carve out some time where we spend our personal time instead of work time trying to get that time to be creative. And I think the AI augmentation enabling us to, power through things that are tedium and give us time to kind of grow through this sort of AI augmentation, whether it be to do a job faster that is really uninteresting and kind of slows down our productivity, or whether it's, to give us unique insights on how we can grow and think about problems differently, or just have the data at hand, right, so that we can make a better informed decision. I think we're going to see that the entire workforces will get smarter, but not necessarily have to work harder at it, right? That's why we would want to use things like AI augmentation, so we can make the better decisions and have that information and insight at our fingertips.
Is there ever a time, even call it in the next century, when we'll achieve what Ray Kurzweil refers to as singularity, kind of the fusion of carbon-based and silicon-based sentient beings, or is that really just science fiction?
For now, I'd say I put it in the science fiction camp. Although, I think areas like AI augmentation will help us, down this path. But I don't think in this century. So I won't see it in my life. Maybe in two.
So I'm not going to see you at the biohacking conferences up here in Silicon Valley, huh?
Not just no.
Scott, this has been fantastic. It feels like we're just getting started. Maybe as some of these trends emerge and you and the team at FICO, do more great work, maybe we'll have you back for another discussion.
I'd always welcome that, Dan. Thank you.
Good. So much more to talk about. Before we let you go, is there a place where our audience could go to learn more about the work that you're doing at FICO?
Yeah, I think you could go to the Twitter handle, at Scott Zoldi, all one word, or visit me on LinkedIn. The other one is we have, a number of blogs that we put out under the FICO blog. And so you could search Zoldi FICO blog and find a lot of what we're doing there and some of the research around these concepts, right hot off the press.
Scott, we are all looking forward to you and the team succeeding. It's important, particularly the work that you're doing with regard to interpretability and AI ethics. So thanks for a really enjoyable conversation.
Thank you so much, Dan. Appreciate it.
This is your host of AI and the Future of Work, Dan Turchin, signing off for this week, but back next week with another fascinating guest.